Imagine a force so powerful it can slice through solid rock, layer by layer, over millions of years, creating one of Earth's most jaw-dropping wonders. That's the Grand Canyon. But how did this massive chasm come to be? What was here before it even existed? And what does the future hold for this iconic landmark? Today we're diving deep, literally, into the science. Buckle up for a geological adventure that'll blow your mind. If you're new here, hit that subscribe button and let's rock this out. First, let's rewind the clock to what was here before the Grand Canyon was even a twinkle in Mother Nature's eye. We're talking billions, yes, billions of years ago. About 2 billion years ago, the story kicks off with a bang. Picture this: volcanic islands smashing into the edge of an ancient continent thanks to plate tectonics. This colossal collision created the dark, twisted basement rocks you see at the very bottom of the canyon today, the Vishnu schist and Zoroaster granite. These are metamorphic and igneous rocks forged in intense heat and pressure, like Earth's own pressure cooker. They're the oldest rocks in the canyon, clocking in at around 184 billion years old. Then fast forward, or should I say slow forward, to between 175 and 125 billion years ago. Here's where it gets mysterious. A huge chunk of time is just missing. Erosion wiped out those rock layers, leaving a gap in the geological record called an unconformity. It's like nature hit the delete button on hundreds of millions of years. Next up, from 125 billion to 730 million years ago, shallow prehistoric seas flooded the area. Sediments like sand, mud, and even algae-built structures called stromatolites piled up and hardened into what's now the Grand Canyon Supergroup, layers of sandstone, mudstone, and limestone. Imagine a vast, warm ocean teeming with early life, depositing these rocks bit by bit. But wait, there's more. Jumping to the Paleozoic era around 508 to 270 million years ago, think dinosaurs weren't even around yet. The region was again underwater in shallow seas. This is when the famous upper layers formed. Limestones like the Kaibab, now capping the rim, shales and sandstones full of fossils from sea creatures like brachiopods, corals, and crinoids. The whole area was flat, part of the Colorado Plateau, with oceans coming and going, leaving behind a stacked cake of sedimentary rocks following the law of superposition. Older stuff at the bottom, newer on top. Before the canyon, no dramatic chasm, just a relatively flat landscape, occasionally submerged, building up these colorful layers over eons. Now the main event, how did the Grand Canyon actually form? It's not some overnight catastrophe, it's a slow burn masterpiece of geology. Remember this easy acronym: DUDE, Deposition, Uplift, Downcutting, and Erosion. We already covered deposition, those layers stacking up like a geological lasagna. Around 70 million years ago, things got uplifting, literally. Tectonic forces from the Laramide orogeny involving the subduction of the Farallon Plate pushed the entire Colorado Plateau skyward from near sea level to over 9,000 feet high. No massive folding or faulting like in mountains, just a gentle rise, keeping those layers flat and horizontal. By about 6 to 5 million years ago, the Colorado River enters the scene. Waters from the Rockies rushed westward, and with the plateau now elevated, the river had a steep gradient, dropping 2,000 feet over 277 miles. Add in the opening of the Gulf of California, which dropped the river's base level by 5,000 feet, and boom, the river starts downcutting like a natural jackhammer. How? Abrasion from sediment-laden water grinding rock like liquid sandpaper. Floods, up to 300,000 cubic feet per second, carried boulders that chipped away at the bedrock. Softer layers eroded faster, creating those iconic stepped cliffs. Tributaries widened the sides, and weathering from rain, freeze-thaw cycles, and wind helped break it all down. Oh, and volcanoes. From 630,000 to 400,000 years ago, lava flows dammed the river at least 13 times, creating temporary lakes up to 2,000 feet deep. But the river always won, eroding them away. The result? A canyon 277 miles long, up to 18 miles wide, and over a mile deep, carved by water's relentless power, amplified by time and tectonics. So what about the future? Will the Grand Canyon keep growing, or is change on the horizon? Short term, erosion continues but slowly. The river will deepen and widen the canyon a bit more, though the Glen Canyon Dam, built in 1963, has tamed floods, reducing natural sediment flow and altering the ecosystem. Invasive species and controlled floods are part of ongoing management. Looking ahead with climate change, studies of ancient stalagmites show that past warm periods like 8,500 to 14,000 years ago brought more summer monsoons and rain to the high plateau. Future warming might intensify these rains, boosting groundwater recharge, but reduced winter snowpack, already down over 16% in the last century, could dry up springs like those supplying water to millions in the park's visitors. The Colorado River, overtaxed for 40 million people, might see less flow, turning low deserts drier while high areas get wetter storms. Long-term, over millions of years, more uplift or tectonic shifts could happen, but the plateau's stable for now. Eventually, the river might reach base level, slowing erosion. But one thing's sure, the canyon will keep evolving, a living testament to Earth's dynamic forces. The Grand Canyon isn't just a hole in the ground, it's a time machine, revealing Earth's epic saga. What blows your mind most about it? Drop a comment below, like if you learned something new, and subscribe for more mind-bending science adventures. Thanks for watching. See you next time.